And I am live. That is pretty cool. Today is 20th of October 2025, Monday. And today we are going to get into QEMU, which is a piece of software anyone can use to emulate, virtualize any other software on their machine. And yes, that is the introduction. Also, we need to know, not this, we need to know two things specifically. There is a thing called virtualization, right? There is this thing called virtualization. Okay, spelling is somehow wrong. And then there is also this thing called emulation. And what are these two things? Yes, virtualization means like since you already have a processor on which you are running your own main host operating system, the new operating system, the virtual OS is the virtual OS that you are going to run also is also or like is running on the same architecture. Yeah, is it is also running on the same architecture almost natively. That is the whole thing about virtualization. So yeah, virtualization is pretty cool. If you want speed, then this is what you should go with. And here we can take some example, I suppose, x64, by which I mean this x86 64. On this, you run x86 64 ISO file or anything. And then for ARM, you run ARM file, right? That makes a lot of sense. But in emulation, we can run binaries of any architecture. So that is kind of cool. Here we will just take two examples because I don't know anything else other than these two examples. We have x86 and ARM, and let's say our host could also be x86 or ARM. And in case of virtualization, on ARM, we only run ARM processes, and on x86, we run x86 processes. But here, like, it doesn't matter. We can do anything, we can run anything, whatever we want. But there are a few caveats. This thing is fast because you are running the same architecture and it is running natively. So that is fast, and there is no translation layer because the instructions match the processor on which the host process is running and the virtual one is running. They are the same, so that is pretty cool. Happy Diwali. Yep, doing something new today. QEMU. Yes, happy Diwali. Will not do Redis project. Not today. Today we are not going to do Redis because it is Diwali. So let's do something like a bit different. And this is difficult. QEMU is kind of difficult. Yeah, it is difficult. It is like virtualization and emulation, which is difficult. And in case of emulation, this is slow. Emulation is slow because there is a translation layer. Yeah, that is if your client or the parasite, yeah, you could call it, if the instructions of your thing, of your operating system, which you are running in the virtual box, they differ from the processor on which your host is running, then there has to be a translation layer in between, which is converting these two instructions among each other. And yeah, converting translations is slow. That is like almost compiling the whole thing again. Yeah, and translation is slow. So yeah, so virtualization is cool instead of emulation. Emulation gives you a lot of freedom, but yeah, not really good. Yo, this is running some other operating system on your operating system in a virtual box, and that is cool. So you think of switching to Arch Linux? Maybe you can try using it on QEMU. Yes, we can use it on QEMU. But okay, so yes, the thing about Arch is, and what will it do? Is it like some config or installation? It is like, okay, so QEMU natively handles like these two things, right? It is a base software which you can access through CLI, and yeah, you can run any operating system you want through either virtualization or emulation. And then there are, since this is a CLI tool and you have to manually put in all the operations manually put in all the operations manually. Instead, there is this GUI, which is a wrapper around QEMU, which you can use to run some other operating system. Yeah, graphically. And here we have Debian running. Let's run this. So, hello. Shit. Yes, there is a problem with this. I did this sudo system suspend command and now it is not taking in any inputs. So I will have to turn off the computer and now start it again. And the thing about using Arch, yes, that is good. The thing about using Arch is that I am using macOS and macOS is ARM based. Look at this. This is running Walrus, my name and my password. And yes, let's go. Let's go. We have a virtual box running and we are running Debian on this. Fast fetch. Shit. New fetch. Here you can see, shit, I cannot use my mouse here. Here you can see that host is QEMU virtual machine. That is nice. Kernel is ARM based, not x86. This is ARM. And shell is bash. Screen resolution terminal GPU 4, GPU Red Hat, GPU, CPU. And look at the memory. Memory is 1 GB. Total memory is 963 MBs, around 1 GB. And this whole operating system, the whole operating system, everything that you're seeing right now is running in only 176 MBs. The whole operating system is running in 176 MB, and that is amazing. That is like very beautiful. Browsers take more than this. Yes, we can run Asahi Linux on M1 processors, the new M1 silicon processors. But I am afraid to use it because I might this laptop that I'm streaming from is not dispensable. So I'm very afraid to change anything that I am not very like comfortable with. Yeah, it just might just blow up my main laptop. So I don't want to get with do Asahi Linux. Yep, OS thing. Uh, which is a arch derivative, I think. Asahi. I don't know if it is arch. Yeah, you can just learn. It is pretty cool and pretty easy. Not pretty easy, but yeah, cool. You can learn it. Past in OS subjects. So let's go. Bro past. You allocated that much memory. Should you think 1 GB is higher than I should be allocating? Makes sense. Uh, yep. Thank you. And yes, the problem with using ARM or like Arch with this is that Arch, let me show you, Arch does not have a lot of, since this is ARM and to get speed, I would have to virtualize, right? Virtualize. And with virtualization, I can only run ARM binaries. And for ARM servers or there are only a few mirrors for this for ARM binaries and like in Germany and the closest one here to here is Singapore. and two servers in Taiwan, and these are not very fast. Yeah, these are not very fast. And in Taiwan, one of these servers is hosted by a national university, and shit. eh, Yes, this one in Singapore is hosted by a guy, by like a single person, a dude. He's hosting a Arch ARM server by himself. That is pretty cool. And the other one in Taiwan is hosted by university, and the other one by National Center for High Performance Computing, Taiwan. And yes, these are not very fast, and they also don't have all the packages which someone might need. Let's actually delete this virtual machine and run Arch Linux, and we will install Arch Linux right now. So that is good. Okay, shit, let's do this. We will install Arch Linux right now, and we will use UTM first of all. And I can delete this. That is fine. Nope, I already have the ISO. Yes, we will virtualize. And here we are using UTM. We are not going to use QEMU right off the bat, right? And UTM is just a wrapper, a graphical wrapper around the base thing which you want to learn, which is QEMU.org, right? So yeah, we will get to this in some time. But before that, let's install Arch. Whoa, let's go. Okay. Uh, ISO, this one, Arch boot. Yeah, this is the one. Look at this. This one is just 438 MBs, and this is for ARM processor. And this one is 1.5 GBs, and this is for x86 architectures, the Intel processor. So this one cannot run on this with virtualization, which you want to do. Virtualization is faster. So we need ARM binaries, and ARM one is 438 MBs. So there are a lot of things which are not going to come in this ISO natively. So we will have to install them. Yo, yep, the difference is huge. So we will have to install a lot of things. And since we need binary files. The servers are not like, they don't work very good. Yeah. But one thing what we can do is we can just somehow install Git, and Git is present, I guess, in the second Taiwan server. Git is present, and we can install Git and then build from scratch every package that you might need. Yes. And we will be building NeoVim. 10 GB is totally fine. We will be building NeoVim from scratch, which is like not very difficult. Let's go. Let's go. Okay. Okay. Yes. This is root. Huh? English. Okay. DHCP. Yes. Domain hey. Dynamic host control protocol. Yes. For getting Wi-Fi addresses, and leave the field empty if no proxy is needed to install proxy server. I don't know what it would be. Ethernet. Okay. So QEMU is like making the VM or this operating system feel that there is a Ethernet connected, even though there is no Ethernet. So that is nice. Asia, Kolkata. And the mirrors. Yes, we will select Taiwan. And yes, shit, I was doing this yesterday, and after this step, it just stops. I pressed enter, and now if I were to press enter, my cursor is at the bottom of the screen. So look at this, it just goes down. Mirror selected is not working. Yeah, that is the problem. We can select the other Taiwan server. So it is checking if the mirror is working or not. And the next one, which we, okay, that one is working. So this one, this Taiwan server is working, and this is why Tam Kang University Office of Information Services. So this thing is good, and this thing, national thing, is not good. Pacman configuration. Okay, we have Pacman. Launch, setup, preparation, prepare, install device. We have to create partition on the 10 GBs which I have allocated to this. Quick erase the entire storage device. Yes, 10 GB. Partial part UUID. Okay. EFI, multi-boot, single boot, EFI, disk left. Minimum value is 260 disk left. EFI partition, the partition where we will be storing our bootable thing, and extended bootloader partition in MBs. Minimum value is 100. Let's go with this. Okay, disk left is this. Swap memory, let's say 500 MBs. And shit, I guess it should be ext4. And why do we have to do all of this manually? Linux, I think it is ext4. Yeah, extended 4 file system. Okay. And file system ext4 will be used for and home. Okay. And disk left this much. Who are we giving the 7 GBs to? Value 0, skip home. Okay, so how much we are going to give to home? How much storage are we going to give to home? Okay, 400. Release. That is fine. All data will be lost. Yes, we are absolutely sure. So all of that is amazing. That looks like pretty cool. Quick setup was okay. Now we have to install packages. We have partitioned the drive, and by drive, we only mean the 10 GBs which I selected when we were going through UTM menus. Next step will install following packages for a minimal system: base and IP tables, NFT, Linux. Bro is installing Linux completely, and terminus font. What we need is just Pacman. But shit, it is installing using a Taiwan server. Yeah, something is happening. That sounds like a solid plan. If enable binaries work, maybe try happening. Okay, that would be too much. That would be too much. That would kill my computer. And I think right now it must be booming or something. Wait, not this. That is a new thing. Okay, it is like not consuming the whole RAM. And there is still something left. But look at this swap memory. A lot of swap memory is being used. But that is fine. That is like, this is not as bad as I thought. Not even 7 GBs is being used. So that is cool. And here, wait, memory percentage. This thing, what is UTM? UTM is taking most of the memory. And then there is the browser, Brave, and OBS. That is nice. Okay. Binaries are loading. And also, there is LFS. This is like a dream. Shit. This is literally a dream. In this, we will be downloading all the source files for the Linux kernel and all the GNU packages which go with Linux, and we will be compiling them by hand manually and putting everything together. That is LFS, and that is just too much. I do have the LFS book. Yes, 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 yes. Uh, Linux. There you go. LFS. Yes. And this book comes out like every month. This came out. This is the new version for September 2025. Just comes out every month. And here we will be installing everything that we need. Look at this. Bash, downloading bash source file, and then compiling it. M4 is something. Make, gzip, grep, gawk, file, dart, bin utils, gcc, the complete gcc, Perl, Python, util Linux, and then all of these packages, gcc again, ncurses, sed is something that I've heard said somewhere. But yeah, we in LSS we will be building everything. So that is kind of crazy, actually. And I wanted to do QEMU today, and we'll do Redis tomorrow. We have written event loop. We only have to write application side code, so that is cool. I get that so much. LFS is a dream indeed. So notorious voice dev. Yo, LFS is like pretty cool. And when I get to know QEMU, like when I'm very good with QEM, okay, packages have been installed. When I'm very good with QEMU, I can do LFS. That would be pretty cool. Yep, we will install and compile. I don't touch that because I feel my knowledge is still very lacking. So, okay, I guess you can touch it and then your knowledge will grow. New root password. Close your eyes. New password is set for root. Okay. And of course, new Vim. Should they literally have new Vim, not even Vim? They have new Vim. Should we don't have to install new Vim on our own? Okay. And TTY1. Should I cannot use my mouse here? But yeah, this is TTY1. Teletyper. Installation failed. That is fine. Configure system. Small pass. Okay, I don't know what this is, but anyways, let's just press enter and everything happens somehow. Shit, shit. Bro will break into my virtual machine. And system configuration. So system management, user configuration, virtual console, local settings, Pacman mirrors. We would like to change the mirrors. Server equals R arm R's. Nope. We would actually like to change this. Wait, is this Vim? Maybe this might be Vim. To this one. tw.mirror.arch. Shit, this is not working now. Okay, it is working now. Falkenstein. tw should not capital. tw.tw2 dot mirror, I suppose. If temple was, we can do that. We can do that at some point. You installing KVM. I don't know what KVM is, but yes, we will get into that. What it is. Binaries running them on QEMU. Let's go. Yep. And so this one is TW, not two, just TW. Okay, that is good enough. And I don't think there is anything else you want to change. Okay, default shell, return to system configuration. Wait, should how modify user account, super user. There is a super user. Exit. Okay, reboot system. Wait, is it done? Is it done? Shit, is it? It is done. It is done. It is done. Now we can close this and and but wouldn't running OS in QEMU alone be a little slow? No, we will be virtualizing. Virtualizing is almost as if you are running the operating system natively on your processor. So that is fast. And QEMU is better than every other thing. Mm, yeah, better than VirtualBox or any other thing on the market. Wait, KVM. Okay, I will have to look up what KVM is. And now before running this, we can just clear the bootable thing. Yeah, we have tried 1 billion row challenge. What is 1 billion row challenge? I was trying to do it for like past 2 days. It couldn't get past 6 to 7 seconds mark. 1 billion row challenge. Okay. KVM and 1 billion row challenge. And now we are not booting from the bootable ISO. Yo, okay, what is this? Uh, this. Uh, okay, that is Arch Linux for you. Standard English. So Francois, continue. Press enter in 3 seconds to skip. Nope. Start. Uh, QEMU virtual machine. Okay, we are in the bootloader. Shit. I think we did not install the thing properly. Shit, we did not install the thing properly. That is, we removed the bootable drive, but we didn't install this properly. So yeah, the OS was not installed natively. So that is why we are only able to access the bootloader and not the OS. That is crazy. Yeah. And for that virtualization, you need KVM. Okay, never a native performance. It is never a what is KVM and kernel based virtual machine, two different technologies, or keyboard video mouse KVM switch. Red Hat, yes, okay. Kernel based virtual machine is an open virtualization technology for Linux operating systems. Okay, with KVM, Linux can function as a hypervisor. Yes, hypervisor is a term that I've heard that runs multiple isolated VMs. KVM was announced in 2006 and merged into the Linux kernel. A year later, many open source virtualization technologies, including Red Hat virtualization portfolio, depend on KVM as a component. So KVM is within the Linux kernel, which we can use for virtualization. I don't think he installed KVM. He just did QEMU. I mean, they are saying that KVM is on the Linux side. Uh, let me install Debian because that is much easier. Because this Arch ISO is just 400 MBs and does not have a lot of things, and yeah, does not work really well. It means install Debian, which is much better, like much easier to install. And the whole problem here is that I'm using ARM and binaries, ISO files for ARM. ARM is like not very common. Debian, go, let's go. And Arch does not have a very good ARM support. Yeah, but Debian does. Debian. Okay, that is running, which is cool. It's like actually cool. CPU memory, etc., is used by QEMU via KVM using QEMU alone and kind of is kind of slow. Okay, so huh, should I messed up? Shit, I messed up. Should I'm changing between TTYs, I suppose. Yeah.
Welcome to VoiceOver.
No.
VoiceOver speaks
Um,
descriptions. Welcome to VoiceOver.
shit, I am. Shit, I changed to the wrong TTY. Okay. Walrus does not matter. Domain name, password for the user. User password. Okay. We have our root user and like separate non-sudo user. Valid disk. Yep. All files in all files in one partition. Finish and do this. Yep. Installing the base system. Let's go. Although for some reason in my previous laptop, KVM just refused to run. Let's ChatGPT, yes, main knowledge source. Uh, what is KVM and how does it with virtualization with QEMU? And for that purpose, what is QEMU itself? And yes, right now we are using UTM, which is a wrapper around QEMU. In a while, we will be using QEMU natively. That would be cool. Scan extra installation. No, no, no. Debian is nice. Blank. Let's break this down carefully from first principles. QEM it stands for Quick Emulator. That is nice. It is a machine emulator and virtualizer, emulator and virtualizer. Yes. In plain terms, it is a program that can emulate hardware, pretend to be an entire computer with CPU, memory, storage, network cards, etc. Virtualize, run guest operating systems directly on your machine hardware, if hardware support exists. And here we have hardware support, I suppose. Let's separate those two models clearly. Full emulation mode, QEMU, quick emulator. So it is like main for emulation. Full emulator mode, QEMU emulates every piece of hardware, including the CPU. You can run software built for a different architecture than your host. For example, run Arch Linux on your ARM Linux on your x86 laptop. I don't have x86, but this is slow. Every CPU instruction must be translated into your host's equivalent. Virtualization mode, when QEMU runs code built for the same CPU architecture as your host, yes, it can skip the emulation. Instead of translating instructions, QEMU can ask your CPU to run them directly but safely inside a virtual machine. This is where KVM enters the picture. What is KVM? KVM stands for kernel based virtual machine. We just saw that kernel based virtual machine. It is a Linux kernel module. So it is within the Linux kernel that turns the Linux kernel into a hypervisor, that is software capable of running virtual machines. software capable of running virtual machines? No. QEMU is pretty great just just testing a basic bootloader you created or just quickly checking the OS. MIT wrote a simplified version of Unix. You can download and run it using QEMU. It is easy. It, MIT wrote a simplified version of Unix operating system. That is cool. Okay, you can run that. And yes, so you'll be using Debian environment. Okay, there are like three things going on. Okay, back to this. Let's focus on this. KVM, kernel-based virtual machine. It is a Linux kernel module, a part of the Linux kernel that runs the Linux kernel into a hypervisor. That is software capable of running virtual machines. Isn't QEMU doing the same thing? Software capable of running virtual machines. In simple terms, KVM is the bridge between QEMU and your CPU's hardware virtualization feature. How KVM helps QEMU. Normally, QEMU, quick emulator, would emulate everything in software. Slow but flexible. With KVM, the CPU itself helps with virtualization. Okay, okay. Modern CPUs have Intel or AMD V special hardware extensions for virtualization. These allow running guest code at near native speed in isolated environments. So near native speed, that is nice. What KVM does, it is shit. So there is a part in the Linux kernel, there is a part in the hardware, like this thing. They have a special hardware extension for virtualization, and Linux also has a special extension for virtualization called KVM. Okay, kernel based virtual machine. KVM exposes those GPU virtualization features to QEMU. Okay, okay. Let's the Linux kernel handle these things. CPU context switching between guest and host, memory mapping and isolation, I/O device management through Virtue, etc. Okay, that makes sense. What QEMU does when using KVM still emulates some hardware like disk, network cards, BIOS, etc., but delegates actual CPU execution to KVM. This means guest runs directly on the host CPU, only device emulation and certain privileged operation go through QEMU, result near native performance. Okay, and here we are using like UTM, which is a graphical wrapper. So I suppose this also has KVM installed. It is just terminal based, no DM, direct message, no GUI, nothing, just some basic GNU core utils functionalities like CD, Meteor, and all. You can literally see its code. It is very easy and small. Okay, I will do it just after this. It is a great start for OS developers. Let's go, OS developers, and we can reboot now. That is nice. Let's no, no, no. Close this, and before running, we will clear this thing, and now we can run. It is running, and now okay, we are inside. And now before moving on, okay, so there are first of all a few things. The KVM thing, I have some hypothesis to what is happening here, and then we will run this thing. But before everything else, we will download and build NeoVim from scratch in this VM. But why did you Arch install seemed different. Whatever I have installed it, and there was never any type of colors. Because my ISO is ARM based ISO, and your probably was x86, and they have different supports. Your must be like 1 GB or something, and mine is like 400 MBs. So I had to install a lot of things. Yeah, there are some guys, this thing, Arch, Linux, ARM. Yeah, I don't know if this is official or not. We are a port of Arch Linux, which aims for simplicity and full control. To the end user, we provide a lightweight beast structure that allows you to shape the system to your needs. And yeah, this is the ARM support for Arch. And let's do some things. So first, we'll go to the root and apt get install sudo, and we will make our like walrus user a sudo user thing. For that, we have man sudo edit sudo mod. Shit, okay. How do we convert a normal user to a sudo user? I think the command is sudo edit mod sudo user linux and user mod sudo user mod add group is sudo walrus the user, and now walrus is a sudo user. And why did we need this? We needed this so that we can install packages. Now sudo apt get install git. That is what we will need. Cool. Yep. 57 MBs download. And we will git clone neovim and we will build neovim. Make dir code bases, and here git clone https clone slash slash whatever.com neovim.git tool, and we can just build neovim, which is kind of crazy. Yo, hello. Because there is a big drama happening when Arch deleted some of its ARM specific binaries from its package manager, Pacman. At that time too, it was widely discussed to rewrite a new Arch for ARM only. There is not a great support, so I guess yes, they should. For Debian, that is why it is easier to run Debian here, because there is a better support for Debian here. While jumping from topics like this, like, because that is kind of good. I've like I cannot stick. It is very hard to stick to one thing for a long time. I have one suggestion: if that you will stop CP, you will lose the grip, and it takes again some time to get back grip on CP. I mean, I can do it. I can do it. I mean, yes, it will take some time to get back the grip, but it is fine. I can, yeah. If I were to continue, I would be forcing myself too much, and I wouldn't be doing OS stuff or anything else, and I would also not be doing CP properly. So yeah, this is kind of better. Shallow clone. It is too big for a repo for just building it. Wait, so don't I need, I don't need everything that is in the Git repo, but doing only CP wouldn't teach anything new. Brother, there are a lot of things in competitive programming. that you can read about. It can it can even teach you about life. Competitive programming is, yeah, you can learn lessons, metaphorical lessons about life. Add a flag depth equal to 1. We have the code base, and now we have to do, I think it was sudo make c make build. Shit, before this thing we have to install dependencies. So apt get install. We need curl, we need text type. Shit, we need curl, we need ninja, and cmake. Yeah, we need cmake. Yeah, so there are a few other things that we will be needing. Let's see. Build. Let's go. Wait, yes. Prerequisites. We need ninja. We have it. Get text. We installed cmake. Build essentials. Build essentials and get text. Ap get build essentials. Okay, that is the wrong spelling. Build build essential. buildessential. Shit. Sudo apt get install. Build essential. Yes. And we also need get text. Get text. Okay. And now cmake or make build or c make build type will be rel with deb info, or let me see, rel with deb info. Yep. Okay, it is building, like something is happening. It wouldn't teach you. CP is pretty great for developing in the thinking and logic, of course, but only doing it would just stagnate a person. I mean, yeah, we need variety. We need variety. Yeah, just install build essential and build deb package. Okay, how do you know all of this stuff? How do you know all of this stuff? That is crazy. That is literally crazy. And yes, after this, we will be getting back to this conversation. And then I really want to get into QEMU. We haven't done anything with QEMU. I think I directly jumped. Watch. Shit. What did you do there? Shit. You have studied a lot, it seems like. I tried running like 12 to 18 distros. Shit. That is crazy. That is crazy. Hello. How is everything? Yes. Okay. And now sudo make install. Let's go. Ninja, no work to do. Wait. Let's go. We have new. We have new. We have new one, that is good. And now let's download my configuration for new one. Make there config slash nvim cd config slash nvim git clone https colon slash slash github.com slash my name and nvim rm or remove everything from nvim-rc to this folder rmrf nvim-rc, and now we will have new configuration like in Lua. Wait, do I have Lua? Do I have Lua? Sudo apt get install Lua. Lua has no installation candidate. Anyways, nvim. Yo, let's go. It is installing download packages. Lazy is doing that. Let's go. It is working now. And yeah, I have like my whole configuration, my whole new Vim configuration. And let's do some CPP right here. Yeah, some competitive programming. Let's do Halloumi boxes. Do I have G++? Do I do have G++? Halloumi dot cpp. Okay, there is already a package. Uh, yeah, int shit, int main and int t std. Wait, shit, I don't have to do all of this. I have my configuration here. Shit, my boilerplate is here. Shit, that is pretty cool. Int n and k, c and n and k, and then vector int a size n for int I equals 0, I less than n I plus c in ai, and now if is sorted a dot begin comma a dot n or k greater than equal to 2, see out yes, else see out no. So yeah, that is cool. That is cool. G++, Halloumi boxes. It does compile dot slash out and go to code or CP31. It is the first question, the easiest question. Copy this. Should can we paste? Yeah, we cannot paste it there. So we will have to do this manually. There are 5 test cases, 3, 2, 5 test cases. 3, 2, 1, 2, 3. And we don't see anything. Anyways, 3, 1, 9, 9, 9, 4, 4, 6, 4, 2, 1, 4, 4, 6, 4, 3, 1, 4, 3, 10, 3, 8, 30, 14, 20, 8, 31 or 13, doesn't matter, 14. And then last one, 1. Yes, 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 yes. And then no, and that is good. That is good. It is working. Shit. Okay. Dash. Hello. You mean distros like void and all? Shit. Void is a distro. That is crazy. Int main void, and you don't have to be scared. The only time waiting for my laptop to be delivered. Old one died 7 years ago. After 7 years. Okay, If it is like not completely dead and the hardware is still working, run Linux. Run Linux on it and it will work just fine. Never seen anyone IRE using Vim motions? Shit, um, shit. I think you were in the wrong part of the world. Yeah, use Neuron. Use Neuron. You can use flag J in Make to use 16 threads building. That is crazy. 16 threads building. Wait, but the number of cores would still remain as it is. So would it actually be like faster? Because the number of cores will not change. Barely past 12, then how part of note out of computer programming can you increase the font size for my old eyes? Shit, I think I don't cannot do this here on this VM. My bad. I do not have full control on this. Shit, yes. We can do a trace here. We can do a trace here. We can do a trace here. And what is this? This is operating system things. Operating system things. We are trying to run Linux on macOS. That is kind of cool. Yes, we can do a trace here right now. That would be cool. During solution of 1 billion row challenge. Okay, yes, I also have to look up this thing. 1 billion row challenge. I found out that Clang is faster than GCC in general. G++ did something like 31 billion cycles, whereas I think you have talked about this before, and I'm forgetting about this. Whereas Clang did 30 or 29 millions. Ah, they'll just speed up building. Okay, let's just use 4J. Okay, why would it speed up? I'm thinking that this is going to create more threads, but even if it is going to create more threads, I still have the same number of cores, right? So how is it better? Mint with the cinnamon on my system since 2018. Yo, Linux, let's go. I mean, you can give anything after J. You give the number of threads. J4 is generally standard. Okay, I'm scared of you. That's what it is. Let's go. I usually do J16. Shit, there are just a lot of things to follow up on. Uh, let's move before moving on. Let's first do this. Then about the threads. We'll take a screenshot in case I forget. Two brain cells. Okay, okay. So okay, for KVM, for the dynamic between the processor, the KVM and QEMU, I have a theory. The processor has dedicated hardware for virtualization and QEMU when it wants to do virtualization doesn't or like shouldn't directly talk to the processor since every processor could have its own interface. So here we have KVM which acts as a bridge between that dedicated hardware and the QEMU using KVM or through KVM. QEMU can talk to the processor to the dedicated hardware on the processor which it can use for virtualization. And okay, and KVM is a part of the Linux kernel. How does that make sense? and KVM is part of the Linux kernel. Okay, let's first make sure that this thing is true because KVM being a part of the Linux kernel does not make a lot of sense if this thing is correct. Do parallelization or bro, it will not use one thread parallelization. But I'm trying to apply the same concept that we were looking into yesterday when like event looping, when we were writing the event loop and we still have a stop running. Wait, how much is it? It is still cool. This is still cool. Yeah. So yesterday the argument for using threads for using a loop, what event loop instead of creating a thread for every connection we get on the server was that threads are slow. New connection, new thread. This is slow. So we use event loop and to reduce the amount of time that the server or the processor is sitting idle. That is why we use event loop and we didn't use thread. So how would creating more threads introduce parallelization if the number of processors or cores is still fixed? Okay, I will look it up. Look it up. So while one is building, instead of waiting, it builds other files. But it's still the same argument. If I have just a single core that can only do one thing at a time, right? This would help in when we have multiple cores, right? But yeah, this would only help when we have multiple cores, and we do generally have multiple cores. So it would be a rare case when using multiple threads is not speeding up the process. And yeah, okay, yeah. So this will help. This would help when we have multiple cores. apt get new fetch. Shit. We don't have new fetch. Uh, we can install and build MacOS homebrew when no, there was Debian. Interesting. Sudo apt update, install new fetch. That is what we did. Sudo apt get update. Unable to locate. You can maybe build from the binary. Bleeding edge. Okay. Git clone the whole thing. CD new fetch. Make install. That is it. And DYLANARAPS. And I'm doing this to see how many cores I have. So that would be nice. Fast fetch. Uh, you might know a person who said NeoFetch is the newer version of fast fetch. So yeah, Akina is written in Rust. Did he just say build from binary? Build from source. Build from source. Git clone. Run DYLANARAPS slash new fetch. And there we go. CD new fetch and make install. Uh, permission denied. So we can do sudo and sudo. Shit. Okay, we have it running. And shell terminal resolution. How do I see CPU 4? So we do have the illusion of using multiple cores. That is nice. That is nice. So yeah, using multiple threads will help us import OS in C++. Wait, no, import not C++, Python. This M series. What is happening? You can see your threads in your process manager. In this thing, what is cores? Said 0.01% of the CPU is being used, seems, and 99.9% is idle. There are a lot of tasks. Only one task is running. That is literally crazy. And swap memory is 549, and almost all of it is free. I literally do not see the number of threads or the number of cores. CPU percent said yes, their number of cores is not there. H top, maybe H top. Let's go. Yep, we have three cores. We have three cores here, and all of them are. We have four cores. Shit, this is zero indexed. We have four cores, and most of them are empty, like not doing anything. That is crazy. So using multiple threads is going to help us. So divide that by two. Python. Bro's laughing. I'm in the market for a new laptop. Don't laugh. I stick with x86. Okay. And I'm using ARM. My bad. It is not H-top or B-top. This is not H-top or B-top. This is H-top. Windows 11 literally takes about 45% of the GPU in my laptop just after booting. Lol. I'm dumb. Shit. No, you are not dumb. Uh, a dumb person does not say that he's dumb. A dumb person says, I'm very smart. And a smart person says, I'm very dumb. A genius admires, shit. An idiot admires complexity. A genius admires simplicity. And that is a nice quote by someone amazing. This is pretty nice. Only a little bit of the CPU is running, and we have two threads. Shit, the whole operating system is running on two threads. That is crazy. That is literally crazy. Okay, shit. And this thing. Shit. Yeah, switching between topics a lot. Exactly. Is ChatGPT just praises every time? Let's go with the long one. Okay, what you said, summarize. The processor has dedicated hardware for virtualization. QEMU couldn't, cannot, shouldn't directly use that hardware since every CPU vendor implements its own interface. Okay, so KVM sits in the middle, a standardized Linux kernel interface to that virtualization hardware. QEMU then talks to KVM instead of processor directly, but KVM is a part of the ISO which we want to run. And if the ISO is talking directly to the processor and the virtual box is using the ISO, something, a module from the ISO which we want to run as a bridge between the processor and the virtual box, that is kind of crazy. So KVM sits in the middle, perfect intuition. The deeper view, three layers of virtualization: hardware, kernel, and user space. On the user space, we have QEMU. On the kernel space, we have KVM. And there we have MMU, memory management unit. Let's go. Okay. On ARM, we have ARM VHE M1 virtual machine hardware extension or something. ARM-based architecture of Apple algorithm, which includes ARM-based virtual machines, ARM-compatible Linux or emulated this thing. We can use UTM or QEMU, but they are not talking about the hardware. Like in the M1 chip, what is the thing? A dedicated hardware which we can use for virtualization. Integrated components has a more integrated design than older, yeah, disintegrated system on chip. Why QEMU cannot directly talk to the hardware? You are right. Every CPU vendor exposes different registers, flags, and control structures to manage virtual machines. Intel, AMD, ARM, A. If QEMU tried to handle those directly, it would need root privileges, which is unsafe for a user space program. Be non-portable, and duplicate kernel-level responsibilities like context switching, interruption, and paging, and page tables. What KVM actually provides is KVM's role is twofold. Exposes a standard API to user space through slash dev slash KVM. Shit. So there is like literally a socket, you could call it, running. Shit. This is IPC, inter process communication. Like literally inter process communication. Huh? Yes. Wait, x86 are not available? What does that mean? Like, what is the intent behind this statement? KVM is part of ISO. That is what we saw earlier, that KVM is part of the ISO, part of the Linux kernel. So it should come with the ISO. Huh? X64 architecture is emulating. Okay, so you are referring to by x86, you mean x86-32 and not x86-64. Yes, yes. Okay, I got distracted. Slash dev. And do we have, sure, we don't have KVM here. We don't have KVM here. We do have a lot of things. We have TTY, a lot of TTYs. FT file descriptor 0, 1. Yeah, crazy. Okay, so create a virtual machine, KVM create, KVM shit. This is inter-process communication through sockets or file descriptors. That is pretty cool. And there is a video on a YouTube channel named Core Dumped on this specific thing, how multiple processes can communicate with each other either by sharing space on the RAM or through IPC or through like sending messages between each other. Hypervisor is also something. So EVM is a Linux module. So does it with ISO that we want to run? No, that is nice. Yeah, that like deals with a lot of worries. Hello, you can try nmap. Should nmap and the other thing. Yeah, 50 50 seems close enough. 50 is close enough. Nope, I'm not done with CP. I'm just not doing it right now. I know it is old. I still use 32-bit software. I like and suits my workflow. Hmm, that is nice. KVM does not come with the ISO binary, so that is good. It comes with the Linux kernel of your host system, the one you are running QEMU on Linux kernel of your host system. So shit, we cannot use KVM on Windows. If you are, but we shouldn't even be able to use KVM on. Yeah, let's let him cook. Let him cook. If you are installing, say, Ubuntu as a guest inside QEMU and your host system, the real machine is running Linux with KVM supported and support enabled. Okay, so whenever we want to virtualize something on a Linux system, we can use KVM, which which is good, which will be communicating with QEMU. So KVM is not part of the ISO that we want to run. KVM is part of the host kernel. Okay, okay, that makes a lot of sense. And can any OS install and run KVM? Think it should be. No, QEMU is kernel-based virtual machine and it is not a standalone program. It is a Linux kernel module. So it runs with Linux, a CPU with hardware virtualization extension. Yes, these two things are needed. Only operating systems that are based on Linux kernel can run KVM directly. All of these, so Mac OS and Windows cannot use KVM, it seems like. mmap is pretty versatile. You can read files with it, allocate memory. malloc is written on nmap too. Shit, it is written on nmap, so mmap is lower in the hierarchy. IPCs and all. Shit, stop using ChatGPT. Use the official KVM and QEMU docs. Like, I want to ask specific questions, and ChatGPT is very good for that. And yes, in a while we will be reading about QEMU, and then we will read the docs. The docs. And some BSTBs too. They do not have Linux kernel, so KVM does not exist on Windows, macOS, and FreeBSD, OpenBSD, Solaris, all these. Hypervisor.framework. macOS has this thing, hypervisor.framework, and not KVM. Okay, and Windows has Hyper-V. So why can't they use KVM? They do provide similar functionality through their own kernel level virtualization. Okay, okay, that makes sense. That makes sense. You cannot install KVM directly on Windows or macOS, but you can run shit. What I can do is install KVM on this virtual machine and QEMU also on this virtual machine and run some virtual machine inside my virtual machine. That is recursion. Yes, this now makes more sense. Windows has Hyper-V, WSL dot Hyper-V runs on WSL. Hyper-V, and WSL. Yes, KVM runs on WSL. In hypervisor, here we are virtualizing, like the Linux operating system is just running like this thing is running here right now. And in WSL, I think Windows subsystem for Linux. How, like, what are the technical details about this, about the WSL? What is WSL? Official docs. Windows subsystem for Linux is a feature of Windows that allows you to run a Linux environment on your Windows machine without the need for a separate virtual machine or dual booting. WSL is designed to provide a seamless and productive experience for developers who want to use both Windows and Linux at the same time. Use WSL to install and run various Linux distros such as Ubuntu, Debian, Kali, and more, Arch, and receive automatic updates from Microsoft Store and Linux, or build your own custom Linux distribution, LFS. Store files in an isolated Linux file system specific to the installed distribution. Run commands like tool bash. So WSL is like a Windows virtual machine for specifically for Linux, it seems. Docs is updated more frequently than GPT, although these things remain consistent over the years. But relying on this method is too inefficient for something since GPTs wouldn't know about updates. Well, when I have specific questions, then going to GPT is much better than looking and searching in the docs. And that is what I think. And then when I don't have any idea about anything, when I don't have any questions, my main question is what is this thing? Then going to the docs makes more sense. Like right now, introduction, QEMU. Shit, my bad. Sorry. Yeah, now better. Like right now, I have a question. Is WSL like a virtual machine specifically made by Windows for Linux? So ChatGPT is a good thing. Like a specifically made for Windows to run Linux. Excellent. Short answer. Not a real VM. It's called compatibility layer. Essentially, a micro VM managed by Windows, a real Linux kernel running inside a lightweight virtual machine using Hyper-V. So our statement is mostly correct for WSL2, but not for WSL1. The system. Okay, I think we are getting way off the topic, and the main thing was QEMU, and we haven't done anything about QEMU. So we'll just get everything off. I want to get to know QEMU. That is the main thing. Okay, let me break it down for you. Thank you. Uh, CPU has special things to run other OS or multiple OS. Mhm. What what happens is different kernel people make different modules to use that function. Like Linux uses KVM, Windows Hyper-V, macOS some macOS thing. Windows is on x64 or 86 CPU, but they are moving to ARM. Shit, Windows is moving to ARM. Mac is already ARM. To run Linux on your Mac, you will need an ARM ISO, so look for it. Yes, I am running Debian ARM ISO, so that is nice. It works like virtual machine, but runs natively and can see your file from host file systems. That is crazy. Something which VMs cannot do freely. Right? Also, as a rule of thumb, if your system can use run Docker, it can run a VM. Okay, as in like in the sense of capabilities, or it has, if I'm running Docker, so does it mean it has the packages which are required, or it has like the capabilities, the hardware capabilities, the specs to run a VM, something like that? Just look for how to run a VM on my system. I am using X system. Yes, VM is running. Like that is nice. Before you lost context, that was for WSL. Okay, I didn't lose context, but yes, WSL makes sense. Yes, yes, that makes sense. And also, you will probably need a graphical output. So best is you use some application instead of TTY, or you will have to manage displays separately. But the thing with graphical display is my computer will die. Literally, it only has 8 GBs of RAM, and yep, yeah, it will die. I won't be able to stream. QEMU is GUI. KVM is the virtual machine module. Virtual machine KVM is talking to the dedicated hardware, and QEMU is the GUI. Yes, QEMU is creating the GUI. Makes sense. And we can access QEMU through CLI, which we will read right here. And by capability, it is like checkmark. It has the functionality. Yeah. Docker also uses virtualization. So if it can run Docker, it will run VM. Shit. So it has the like physical hardware for running Docker for virtualization. It won't die. It will die. It will die. Uh, this is this is like actually much better if even if I give 1 more GB of storage or RAM of shit. No, this is not good. Look at the swap memory. This is almost hitting the ceiling. 3 GBs of swap memory. Uh, Somehow I have 1,000 threads. I think I can run it, but should I can run Omarchi, but there is no ARM64 equivalent of it. On the official website, it just says download the ISO, and it is not asking for the architecture. It just says download ISO. And I used to run VM on 4 GB 2012 Dell laptop. That too with a U processor. Shit, U is like ultra low processor. Ours can run very easily. Said, okay, I will run the whole thing. Okay. Trust me, you can run on 2 GBs too. Okay. So I will do something with this. And Docker uses containers. It is not the same as VM. I'm not going to argue with that. I don't even know about how Docker works. ARM. Arch does not have a very good ARM support. The with this. Oh, shit. Which paper? Shit. Wait, let me linguistics compute documents so that you guys won't see anything here. This is downloads. Mark. Okay, there is nothing here. You can look at this. OS. Yes. This is the Arch ISO, and this is support because I would be needing binaries, so support is necessary. This is only 438 MBs, and yes, a lot of things are missing from this. Yeah, a lot of things are missing from this, and I would have to install them. And the servers are not very good. There is a server in Taiwan which is not very fast. Okay, I will like, yeah, I will figure it out. I will figure it out and I will run it and I will show you. I will show you on Discord. I'll show you everything. I've been saying this for a long time. Let's just leave all these computers and silicon. Let's go back to farming, and that's the best. Yes, let's go there. Let's go there. We will do push-ups, pull-ups. We will go to gym. Okay, let's do this. QEMU, virtualization accelerators. QEMU's system emulators, and shout out to yes, shout out to Mr. Fabrice Bellard. If you go to his website, bellard.org, you can look at some of the projects by him. Tiny obfuscated image decoder, TinyPy, a lot of things. And we have QEMU by this guy. And Also FFmpeg by this guy, and TTC, Tiny C compiler, QEMax, Quick Emacs, Tiny GL, fast subset of OpenGL. Those are all by this guy. And this is his HTML skills. Yeah, this is his HTML skill set. So yeah, that is cool. Fabrice. Wait, why is his painting like this? Shit. Okay, yeah. French computer scientist, Fabrice Willard. Shout out. And we can turn off this thing. Yeah. Some big Twitter pages why yo, yes. Primogen and yeah, Lex Friedman said that page file and eating away SSD endurance. Apple likes to skim on hardware. It was like 1 TB variant, and it should be fine because it uses a different size of modules. It is eating away at SSD intentionally. Java took on Rust over the Rust writers was what Java it took. Why is Firefox FSM broken for so long? No idea. And to the thing. Yes. On host Linux, we have KVM. And on macOS, we have hypervisor framework, HVF. That is what we will be using. And host architectures, ARM. Yes, because macOS also runs on Intel chips. Memory, emulate, and emulate devices to run a guest OS. It supports a number of hypervisors known as accelerators. So hypervisors is a category. What is a hypervisor? And yes, in this case, something like ChatGPT would not be very cool, but VMware, it's Red Hat. Yep, let's go. Why not? I let's go IBM in Nutanix IBM. Right. Okay. Hypervisor. These are the two guys, not guys and gal. What are hypervisors? A hypervisor is a software that enables multiple virtual machines, each with its own operating system, to run on one physical server. Shit, the fact that they are calling this native hardware, the physical server is very nice. Physical server, where they are calling this a server. That is actually like cool and makes sense. Physical server. Yep, this is a physical server. The hypervisor pools and allocates physical computing resources as needed by the VM, enabling efficiency, flexibility, and scalability. So on Linux, the hypervisor is KVM. On macOS, the hypervisor is literally called hypervisor. Okay, sometimes called a virtual machine monitor, VMM. The hypervisor manages VMs as they run alongside each other. It separates VMs from each other logically, assigning each its own slice of the underlying computing power, memory, and storage. This prevents the VMs from interfering with each other. For example, if one OS suffers a crash or a security compromise, the others survive. Okay, so not only it is acting as a bridge between the virtual machine and the hardware, this could be talking to multiple virtual machines at the same time. So that is nice. And they are separated. So like this is like the browser with multiple tabs, kind of hypervisors hit the mainstream. Okay, most physical computers could only run one operating system at a time. This made them stable because computing hardware only had to handle requests from one OS. The downside of this approach was that it wasted resources because the operating system can only sometimes use all of its computer's power. Huh? The downside of this approach was that it wasted resources because the operating system can only sometimes use all of them. Okay, so An operating system is not like going fully guns blazing all the time. And when the CPU is sitting idle, here, quite a bit of this is sitting idle. Yeah. So we could be running a whole operating system here on the idle part. A hypervisor solves that problem. It is a small software layer that enables multiple instances of operating systems to run alongside each other, sharing the same physical computer resources. This is called virtualization. Aha. And the operating system interfaces referred to as virtual machines are software emulators of physical computers that run on the host machine. That makes sense. That makes sense. So we can conclude without getting into shit. This way of talking, when you have a like transparent mirror, glass or something, and the person is writing on it, that just looks very cool. Casey Muratori also uses this way of like explaining things, and this is pretty cool. This is pretty cool. This is like magic. Like the alignment has to be different because the person would be writing in like what is their right and left, and the camera is on the other side, so the alignment has to be switched horizontally on the x-axis to on the y-axis to make this thing make sense. That is cool. And back to this thing. Okay, so hypervisors. So then gets to is it supports a number of hypervisors. All of these hypervisors. These are also called known as accelerators. So we have Mac hypervisor framework HVF on macOS. Yep, we will be talking to HVF here. Shit, different levels of hypervisor. x86 64-bit. I mean, don't you have both versions of x80 86, 86 64 version and 32 version? X86 doesn't mean 64 by default. There are two versions. X86 32. If I'm wrong, that would be crazy, but I think I'm right here. X86 and x86 64. Shit. Shit. There was, I think it was curl. Let me show you. Keep in mind this number 1386. Keep this number in mind 1386. I 1386. And make file.am. I yes. I 1386. Spotted. Shit. Okay, shit. So curl. I don't know why this number is what this number is doing here, but yeah, this is doing something here in the curl code base. EMB 64. Yep. X86 means 32-bit, and then we had later x86 64, which is a 64-bit computer. That is the thing. Yep. Cool. Going on right now, more than 20 plus big sites down. Shit, YouTube is working. Yep, it is working. That is nice. My stream is working. Wait, LinkedIn working? Yep, LinkedIn is working. And on to this thing. Shit, did Mr. Robot happen in real life? Mr. Robot, IRL. Okay. Features overview. System emulation provides a wide range of device models to emulate various hardware components. We don't want emulation. Emulation is slow. Various hardware components you may want to add to your machine. This includes a wide number of virtual I/O devices which are specifically tuned for efficient operation under virtualization. Some of the device emulation can be offloaded to the main QEMU process using either vhost user for virtual I/O or multi-process QEMU if the platform supports it. QEMU also supports directly passing devices through to guest VMs to eliminate the device emulation over it. Okay, QEMU provides a rich and complex API which can be overwhelming to understand, while some architectures can boot something with just a disk image. Those examples allied a lot, elite, new word. There was a key map, omit, shit, okay. Those examples allied a lot of details with defaults that may not be optimal for modern systems or okay for a non-x86 system where we emulate a broad range of machine types. The command lines are generally more explicit in defining the machine and boot behavior. You will often find example command lines in QEMU system emulator targets section of the manual. While the project doesn't want to discourage users from using the command line to launch VMs, we do want to highlight that there are a number of projects dedicated to providing a more user-friendly, like UTM, and those built around the lib virtual framework can make use of feature probing to build modern VM images tailored to run on the hardware you have. That said, the general form of QEMU command line can be expressed as this. That is what our target is. QEMU command line. That is our target. Again, share. I think that is twice this year this happened. Quora down. Wait, what? Are you 100% certain what you believe? Not an ounce of doubt. If it is down. No, it is not down. Uh, Quora work wall machines. Yep, working. Cool. This is working. Maybe it is up, back up again. Libwork. AWS amazing. Snapchat suspended. Supercell. Duolingo is down. Shit. How is bro going to learn German now? Libvirt also provided GUI and all IIRC. Libvirt, what have you been researching on Quora? I was looking up some reference. Cloudflare must have picked up the slack. Yo, panic is a nice word, by the way. Kernel panic. QEMU system x86-64. This is our target system that we want to emulate. And machine options, CPU options, accelerator options. This would include something like KVM, in this case, hypervisor framework, my bad. And then we have device options, backend options, interface options, boot options. This is the general form. Help. Yes, we can use help. Okay, let's not pretend and yes, remember to hydrate. Let's go. Wait, Indian old songs are famous in Germany. That is Es ist nichtig. Es ist gut. Let's, we can delete this thing. Right. Applications. Move to win. That is how you have to delete things. And here, my bad, on Mac. So we have deleted UTM and we will be using QEMU now. That should be enough. Yes, it is downloading. So this is the thing, we can use help me, and most options will generate some help information. For example, this thing will list the machine types supported by QEMU binary help. Help can also be passed as an argument to another option. For example, should we are giving argument to options inside CLI, that is crazy. Devices, we want to know about devices, and SCSI HD help, give us help me, and these are the options. And machine, this thing will list the arguments and their default values of additional options that can control the behavior of the SCSIHD device. Okay, we want to know about a device. Which device? This device, and give us help. Okay, machine, define the machine type, amount of memory, etc. The hardware specs, CPU is also hardware, but okay. Machine type and number, topology of virtual CPUs. Virtual CPUs, virtual CPUs makes sense. Most accelerators offer a host CPU option which simply passes through your host CPU configuration without filtering out any features. Yes, right. The dedicated hardware for virtualization. This will depend, accelerators. This will depend on the hypervisor you run. For Mac, we have hypervisor framework, HVF. Note that and for Linux, we have KVM. Note that the default is TCG, which is purely emulated. So you must specify an accelerator type to take advantage of. Shit, if I'm understanding this correctly, then this is actually crazy. Default hypervisor is emulated. That is crazy. You use a hypervisor so that you do not have to emulate and you can virtualize and run the ISO almost natively. But the hypervisor that you are using by default, it itself is emulated. So that is crazy. That is crazy. Actually, one more time, you open file manager and I will hit. Yes, yeah. Now shit, it is shit. Recent is also my bad. I will have to change. Fuck. I will never do that on stream again. Devices, additional devices that are not defined by default with the machine type. Okay. Backends, interfaces, devices. Yes, we can say devices which are connected. And backends are how QEMU deals with the guest's data. For example, how a block device is stored, how network devices see the network, or how a serial device is directed to the outside world. Okay, I guess we will get to know as we move forward. Yo, let's go. This is what we need. This is what we need. Type virtualization on machine. Machine is going to be virtual. Virtualization is on. A What is the goal of today's stream? To get to know QEMU so that we don't have to use UTM and we can just use QEMU from the command line and run virtual machines from the command line. That is crazy. We can set up the machine, the CPU, accelerator, devices, backends, machine. Okay, okay. Here in the following example, we first define a virtual machine. Type is virtual, which is a general purpose platform for running Arch 64. Guess makes sense because this is virtual. The guest should also be Arch 64 because here we are specifying Arch 64. We enable virtualization, so we can use KVM if our host is Linux inside the emulated guest. Oh, shit. We enable virtualization, so we can use KVM inside the emulated guest. Virtualization and emulated. If we are doing virtualization, then how is the guest emulated? And are we emulating the guest, a Linux ISO, and on that emulated guest, we are running KVM to run whatever we want to run virtually. And if that is happening, then that does not that is crazy. GPU pass through on my desktop to play Windows games bypassing anti-cheat. Yes, well grinned. Something so I asked if there is a goal. Yeah, the goal is to be able to launch a virtual machine from the CLI using pure QEMU and not any wrapper like UTM. And so Valorant anti-cheat. It is Valgrind or something? Vanguard, yeah, Vanguard anti-cheat. Yeah, bypassing anti-cheat. Here you are saying the machine is virtualization on, flash, whatever it is, flash one, this thing. And memory. Okay, memory is this much. Makes sense. And then when we define 4 CPU max accelerator TCG. Shit. TCG, I think we should not do TCG. We should use hypervisor framework on Mac. We then define the 4 virtual CPUs using the max option, which gives us all the ARM features QEMU is capable of emulating. Why are we emulating? Okay, shit. They suppose, like this documentation supposes that the host is x86 and this thing here is the target. And if this is the target, then and if this is the target, x8 Arch 64, like yeah, ARM is the target and the host is x86, then how can we enable virtualization on such a device? Because we cannot do virtualization here. What we can do is we can use the TCG accelerator, which would be emulated. Okay, I'm just like making theories. Yes, we would have to use HVF instead of TCG because here they suppose that the host is x86. We then define 4 CPUs. Okay, let's just give this thing a read. Okay, then we specify four CPUs, SMP4, SMP, SMP4, and using the max option, which gives us all the ARM features QEMU is capable of emulating. Okay, we enable a more emulation-friendly implementation of ARM's pointer authentication algorithm. We explicitly specify TCG acceleration, even though QEMU would default to it anyway. As the virtual platform doesn't have any default network or storage devices, we need to define them. We give them IDs so we can link them with the backend later on. Okay, so we are specifying IDs, devices. This is one device. Drive equals HD. Okay, and this is for network. Then we connect the user mode network to our network device, as user mode network isn't directly accessible from the outside world. We forward local port. Wait. Then we connect user mode networking to our network device. User mode network, like literally my Wi-Fi, as user mode network isn't directly user mode inside the emulated version, I suppose. Okay, inside the emulated software that we are running. As user mode network isn't directly accessible from the outside world, we forward local host port 2222 to the SSH port on the guest. Okay, net dev user host forward TCP to this thing. We connect the guest visible block device to an LVM partition we have set aside for our guest. Okay, a lot of things are happening here. Block dev. Okay, you then tell QEMU to multiplex QEMU monitor with the serial port output. We can switch between the two using keys and the characters backend multiplexer. As there is no default graphical device, we disable the display as we can work entirely in the terminal. All of that thing is all of this is crazy. Finally, we override the default firmware to ensure we have some storage for EFI to persist its configuration. That firmware is responsible for finding the disk, booting grub, and eventually running our operating system. Okay. A lot of terms have been used in this small introduction that I do not understand. Literally, feature overview. And then this is the running part. Disk, where is virtualization part? User mode emulation, developer information. Yes, we might want to do some uh, pull request onto this thing. Happy streaming, yo. Okay, this is very late. You should sleep. 2 p.m. That is very late. GDP usage, invocation. Okay, so in this, like in the first introduction thing, we got the thing ready, running, and now we are invoking. How do we do invocation? And shit, this is just dense documentation. I guess jumping straight into something complex like this is not very helpful. Yep, not really. Well, I would say this would be it for today's stream because today is also Diwali, and yeah, this thing is not going to make is not making a lot of sense. QEMU tutorial getting started with QEMU. Welcome to QEMU documentation. That is not good, but this thing is. Yeah, I just need to know, read, and study a lot of things to run QEMU like this. Right? There's a lot to take in. Let's break it down. Yeah, sure. Okay. That would be kind of it for today's stream. Because Diwali, yeah, I can use that as an excuse. Today is Diwali, and also, yes, today is Diwali. I'm not imagining things. And also, this thing is very complex. And it would be better if I do some research of my own and then do a stream on QEMU and go through whatever I understand, and we will boot up a device using QEMU. We will boot up a machine, virtual machine, using QEMU, and we will run Linux there. Arch Linux would be pretty cool. Yeah, that would be it for today's stream. Shit, my camera is there. Yes. Yep, that would be it for today's stream. And today we did learn quite a lot. This was dense, and that is okay. Yeah, that is pretty cool. And that would be it for today. And thank you for being here. Bye.